Hello and welcome to Kennedy Space Center, NASA's home for launching humans into space. I'm John Coward, an engineer who works out here at the Space Center. What I want to talk to you a little bit today in this program is the wildlife here at Kennedy Space Center, and then we'll talk quite a bit about how we get shuttles ready to go fly and launch those humans into space. Another beautiful day here at Kennedy Space Center. Now the Space Center is located on a barrier island called Merritt Island. We have about 140,000 acres here on the Space Center, but we only use around 6,000 for processing all the flight hardware. So in 1963 we turned over the land we weren't actively using to the U.S. Fish and Wildlife Service, and they established the Merritt Island National Wildlife Refuge and the Cape Canaveral National Seashore. So we have a lot of wildlife here on the Space Center. We have 5 active bald eagle nests located here. We also have about 300 manatees, which accounts for about 30% of all the manatees in Florida. And somewhere between 4,000 and 6,000 gators live here on the Space Center, which sometimes creates a problem, but not too often. So what you see here is this very high-tech stuff going on in the middle of a national wildlife refuge, and we're very proud of that. I'm out here on runway 33 of the shuttle landing facility, also known locally as the gator tanning facility, because if you're one of those 4,000 to 6,000 gators that I talked about earlier that lives out here on the Space Center, this is a wonderful place to come and sun yourself before you go out for the day's hunt. So we have teams of people who are trained to come out here, probably one of your more interesting jobs, and get any gators that might be sunning themselves off the runway before the orbiter comes in to land. Here on this 100-yard wide, 3-mile long strip of concrete, just a great place. Now, we get orbiters here at Kennedy Space Center one of 2 ways. They either land from space here, and because of modifications that we've done to the orbiter, such as beefing up the landing gear and adding that drag chute you see, this has become the primary landing site. But if it comes on the back of the 747 after having been out in California, well, we've got to get it off the back of that 747. And what we do is we take it over to our 11-story high mate-demate device located over here before we take it to one of our orbiter processing facilities also located off here to the side. Now, right across the river from the Kennedy Space Center is the Cape Canaveral Air Force Station, where we launch a lot of unmanned rockets. Included in the stable of rockets that they have over there are the Titan and the Delta and the Atlas, all very, very good old rockets. But our main concern today is going to be the Space Shuttle, so let's go ahead and start talking about that. Now, the Space Shuttle, what you folks oftentimes refer to as the Space Shuttle, is what we call the orbiter. The orbiter is just one of 4 components that make up the entire Space Shuttle. You have the 2 large solid rocket boosters, the white things on the side, and you have that big orange external tank right there in the middle, and then hanging off the external tank is the winged orbiter, which is where the astronauts ride up and down and when they're up in space. It amazes me to think that in just 8.5 minutes we take this whole Space Shuttle, which at launch weighs about 4.5 million pounds, and we take that, and in 8.5 minutes we go from 0 to about 17,500 miles per hour and about 80 miles in altitude and about 1,000 miles downrange. Really an incredible ride if you're sitting on top of this rocket. Now let me give you a quick tour around the outside of the orbiter. And it takes a lot of time, a lot of people, and a lot of work to get an orbiter ready to go fly. I'm located here in OPF Bay 1 right now underneath the orbiter Atlantis, where they are preparing for the next flight. Now what you see above me are some of the 25,000 unique individual tile that we use on the orbiter to protect it from the heat of re-entry. Now in some of the cooler areas, like along the top of the wings and the sides of the payload bay, we can use these cooler blankets that you see right here. But here on the bottom of the orbiter, you see an awful lot of these big black tiles. With me here is Dave Flowers, who will tell us a little bit technically about that tile.
Hey John, the black tiles on the orbiter are used to protect the orbiter from roughly 2,400 degrees Fahrenheit during the re-entry phase. They range in roughly 1 inch to 4 inches in thickness, and in order for us to glue them to the orbiter, because the aluminum structure expands and contracts at a different ratio than what the tile does, we use a felt pad that we glue to the tile and then glue that to the aluminum structure of the orbiter.
Thanks, Dave. Appreciate it. As Dave alluded to here, during the re-entry, these tile can take up to 2,400 degrees, but the skin of the orbiter is made of a very unexotic aluminum. It will begin to stretch and anneal at around 350 degrees. So what these black tile have to do is dissipate somewhere in the neighborhood of 1,700 to 2,000 degrees of heat in order to protect the aluminum structure of the orbiter during re-entry. Now what we want to do is go upstairs and look at some more of the orbiter. other parts are getting prepared to go fly, such as the cargo bay. Now we're located up near the forward portion of the orbiter, looking back into the cargo bay and towards the aft. What you see behind me is some of the prep work that must be done. Now every single payload that we fly on the space shuttle has different electrical, mechanical, fluid, and data connections. So after every mission, everything is stripped out of the payload bay, and then we put all new stuff in to adapt to whatever the new payload is you're flying. Now what you see behind me, you have one payload bay door open and the other one closed, is a very unusual configuration. We're in the middle of doing some very intensive inspections on board this orbiter right now. Now downstairs, we were talking about the black tile and how they can take 2,400 degrees. Well, now we're located along the leading edge of the wing of the orbiter, and here the temperature can exceed 3,000 degrees Fahrenheit. So we need a special material here called reinforced carbon-carbon, or RCC, this gray panel you see beside me. You see RCC located on the wing's leading edge as well as the nose cap of the orbiter to protect it from the extreme heat of re-entry. Now this is a really cool place to be because this is the business end of the orbiter, only you really wouldn't want to be here on launch day because there's a lot of things going on. But this is the high energy end of the orbiter, because what we have located back here are the main engines as well as the orbital maneuvering system and reaction control system jets. Now right behind me is part of the orbital maneuvering system. That's a very large 6,000-pound thrust engine. We have two of those located back here to give the orbiter that tiny extra bit of thrust it needs when we get on orbit in order to keep it up in space. But also located back here are some of the 44 smaller rockets that we need. What you're looking at now are some of the primary reaction control system jets. Those generate somewhere in the neighborhood of 700 pounds of thrust, and they give us pointing and steering ability when we're up in space. But there are also some smaller 25-pound thrusters called verniers that give us some very fine adjustment when we have to do some very small maneuvers up there. Now the chemicals that we use in the orbital maneuvering system and reaction control system are hypergolic. And here's where I hope to convince you that I am a rocket scientist. What hypergolic means is these chemicals hate each other. When they touch, they explode. So all we have to do is open two simple valves that allow the monomethyl hydrazine and the nitrogen tetroxide to flow into the combustion chamber, and boom, I have rocket propulsion. A very, very simple system. But the downside of it is it's very, very toxic. Whenever you see people working with these chemicals, you'll see them essentially wearing a spacesuit because it is so dangerous. If they would get a good enough whiff of these chemicals, they're going to the hospital because they could have done some very serious damage to their bodies. Now also located back here, as I said, are the main engines, the three of them. What you're looking at right here is the hole where main engine number 1 will go when it finally gets installed. Down below me will be the spots for engines 2 and 3. But right above the main engine is the vertical stabilizer. And that white panel you're looking at right there is where the drag chute is located. The drag chute is used upon landing. You'll see that come out, and it helps slow the orbiter down after a space mission. Now right behind me is the crew module of the orbiter. Specifically what you see behind me is window 1. The commander would be sitting right behind that blacked out covered up window that you see right there. There are actually 2 decks inside the crew module area itself. There's the upper deck, or the flight deck, where the commander, the pilot, and 2 mission specialists will sit. Downstairs from them, well below me, there would be 3 or 4 more astronauts when they fly up into orbit. But this is where you want to be, folks, if you're an astronaut, sitting inside this. If you look at the front of the display that the astronauts are looking at, you'll see the 3 CRTs for the 5 computers that we have on board the orbiter. These 5 computers are running all the time, checking each other. If any one computer gets a different answer than the other computers, that computer is voted out. All the other computers go to tribal council, and he's voted off the island. No, they really do. That one computer will be turned off because he got one bad answer out of the thousands of answers he's calculating every second. That's just the way we work. Our flight rules say that's not an emergency, but we should come home sometime soon. Now that's just getting the orbiter ready to go fly. If you remember, I talked about other components that we have. The other components are the solid rocket boosters and the external tank. I'm here inside the Vehicle Assembly Building, or the VAB as we call it. It is the thing around here which dominates the landscape in Central Florida. At 525 feet tall, it is monstrous here inside the building. Now what happens, back in the old Apollo days, we used to build the Saturn V up in here, and at 363 feet tall, when it would roll out to the launch pad, it would just barely clear the doors as it was heading out. But nowadays we stack the space shuttle inside this building. The way we do that is we build up on top of the mobile launch platform. We'll stack the solid rocket boosters and then add the external tank. Now the solid rocket boosters are composed of 4 components, and each one of those are called solid rocket motor segments, or SRMs. When we stack those SRMs one by one on top of the other, we can do it left, right, or left, right, right. We've done it both ways. It doesn't matter. But once we've got those solid rocket boosters fully stacked, we're ready for the external tank. The external tank is a huge empty aluminum tank with a lot of foam around it. Overall, it's 154 feet long, 27.5 feet in diameter. When it's empty, it weighs about 55,000 pounds. But when it's full of 500,000 gallons of hydrogen and oxygen, it weighs 1.5 million pounds. So once we've stacked those boosters, we gently lower that external tank down in between them and attach it in 4 locations with explosive bolts. Now we're ready for the orbiter to be brought in. We go over to the orbiter processing facility and we get the orbiter out. Whichever one is ready, we put it on the back of this 96-wheel vehicle. We bring it over to the vehicle assembly building where we attach 2 of our cranes to it. We take it from horizontal to vertical, lift it way up high, and then we gently lower it down and attach it to the external tank in 3 locations with explosive bolts. We'll stay in the vehicle assembly building for about 1 week doing all of our preparations before we go out to the launch pad. We're validating all our interfaces and doing some simple checks. Once that's done, we're finally ready to roll out to the pad. This brings me to a point. Right next to the vehicle assembly building is the Launch Control Center, where we have our 4 firing rooms where we can control the launch of the space shuttle. Right now, I'm located in firing room 1 of the Launch Control Center. This is the nerve center for all testing operations that go on with the space shuttle. No matter where the orbiter is, whether it's in the orbiter processing facility, at the pad, in the vehicle assembly building, or even out in California, if there's testing being performed on the orbiter, this is where it's controlled from. These are the consoles where the engineers sit, and especially on launch day. Now, these consoles contain about mid-70s computer technology. I understand that's very old, but to upgrade it would be very expensive. But we understand how the system works, and it's been very reliable for all these years. Now, right up behind me is Management Row. Let's go on up there and have a look. Right now, I'm located in the top of the firing room at the launch director's console. This is where the launch director sits on launch day. Now, this room is usually full of people and very, very busy on launch day, and this person right here is the one who's ultimately responsible for the safe launch of the space shuttle. But I got to tell you, this is where you want to be, because located right outside these windows is the best view on launch day. Welcome to Launch Pad 39A, where we've launched about half the space shuttles. What happens is when the whole shuttle vehicle arrives on the back of the mobile launch platform, you see that incline behind. Well, that's about a 5% grade, so the back end of the crawler's got to jack up by as much as 6 feet in order to keep that whole stack level while getting up to the pad surface. What you see up there right now is a mobile launch platform after the crawler has left, and that would have the space shuttle vehicle on top of it if we were about to go launch. Now, you also see up there something called the rotating service structure. What we do before the shuttle even arrives out at the launch pad is we bring the payload out to the pad and we insert it inside that payload changeout room. What happens is there's this big canister that looks almost exactly like the shuttle's payload bay. We'll bring the canister out, we'll pick it up, attach it to the payload changeout room, we'll open up all those doors you see there, and then this thing called the payload ground handling mechanism, or the PGM, will reach out, grab the payload out of the canister, pull it inside the payload changeout room. We close all the doors, we can lower the canister down to the ground, then the whole shuttle vehicle arrives. We bring the rotating surface structure around to encompass the vehicle and provide protection from wind, rain, and digested seagull food. And then we can open up the payload bay doors on the orbiter. The PGM will take the payload and insert it into the orbiter. We close all the payload bay doors, we bring the rotating surface structure back, and then we're ready to go fly. Tell you what, why don't we go on up there and have a closer look at the pad. Welcome to the 195-foot level of Pad A. Now, I'm wearing a hard hat today because there's no shuttle vehicle out here at the launch pad. But if this were launch morning and we were getting ready to go fly, the astronauts would just be in their spacesuits and they would come out of this very same elevator, walk down this path, and right out there would be the swing arm, which takes you out to the white room where you crawl inside, we lock the astronauts inside, and they get ready to go launch. Also up here on the 195-foot level are the escape baskets. If during the final hours of the countdown there were an emergency and the crew were in the space shuttle, they would come running out of the crew module, come down this way, and then jump in one of these 7 slide wire baskets, hit a very simple mechanism which would release them, and they would slide down the wires to a safe area down at the bottom of the hill. Finally, about 4 hours prior to launch, after we verified the whole vehicle is ready, someone gets to go wake up the astronauts in the crew quarters, if they're even sleeping. I don't know exactly what they'd be nervous about. But then they all get up, have their breakfast, get their final weather briefing, And then they put on their orange pumpkin suits and hop in the Astrovan, do their famous walkout, wave to everybody, and then they take that 20-minute ride out here to the launch pad. Once they arrive downstairs, 255 feet below us, then they hop out, get in the elevator, and take the ride up to the 195-foot level. And then once all the astronauts are safely secured inside the orbiter, we close the hatch, and all the really, really smart people in NASA get 3.5 miles away, leaving these 7 astronauts with about an hour to an hour and a half to contemplate the career decisions that they've made, which led them to be sitting on top of this explosive equivalent of a small nuclear weapon. There's really not a whole lot for the astronauts to do during that final hour and a half. So the astronaut commanders, they try to keep things light, I'm sure, inside the crew module during the final phases of the countdown. When we finally get to T-minus 6.6 seconds, we begin to ignite the main engines on the back of the orbiter. Now, it only takes 3 seconds for them to come up to full power. And so you might well ask, well then, why do you start them at T-minus 6.6 seconds? Bear with me here. The reason is, as those engines ignite, they will bend the external tank as much as 3 feet up at the very top because of their thrust. And it takes them about 6 seconds to bend and then twang back to pure vertical. And that's why we do it at 6.6 seconds. We don't want to be launching when the orbiter and the whole vehicle is bent like this. So finally at T0, we're all ready to go. We are so sure that the solid rocket boosters are going to ignite that we send the command to blow the bolts, holding the vehicle to the ground first. Then we send the command to ignite the boosters.
10, 9, 8, 7. We have a go for main engine start. 5, 4, 3, 2, 1. And liftoff of the Space Shuttle Endeavour on the first spacehab mission and the retrieval of the Eureka spacecraft.
Each booster then goes from 0 to about 3 million pounds of thrust in less than half a second. That's quite a kick in the tush if you're sitting on top of the orbiter. And then they begin their climb out. You'll see when it gets to a point just about where it clears the launch tower there, that's where we turn over control from here in Kennedy Space Center to the folks at Johnson Space Center in Houston, Texas. It continues its climb out about 2 minutes and 6 seconds into flight. The boosters are done. They are jettisoned. They continue on in a giant arc somewhere about 150 miles out in the ocean. As they begin to fall back towards the Earth, a small chute will come out, and that will pull out 3 larger parachutes, which will gently lower the booster down into the ocean, where we have one of our ships and our NASA Navy waiting for it. They'll go out there, install a plug in the bottom, pump some of the water out, or pump air in, whichever way you want to think about it. Get the water out of there. The solid rocket booster will begin to float like this. Then we tow it back over here to the Cape Canaveral Air Force Station, where we clean it, inspect it, take it apart, and then we send it back to our friends in Utah at Thiokol. They will refill it with propellant, and then they send it back to us, and we reuse it. Now, this is all what's happening downstairs. You may remember when we last left our 7 heroes, they were still going upstairs with the external tank attached. 8.5 minutes after T0, the external tank is essentially empty. It is jettisoned. It will continue on in its own giant arc, but usually somewhere over the South Pacific or the Indian Ocean, it will re-enter the Earth's atmosphere and burn up. Once we're up in space and we're in a nice orbit the way we want to be, one of the first things we do is we open the payload bay doors on the top of the orbiter. We do that because the payload bay doors, the inside of them, are giant freon-filled radiators that are used to cool all the hundreds of electronics boxes, as well as the cooling for the astronauts who are in the crew module. Once all that's done, we're ready to begin all that really cool stuff they have to do up in space. The astronauts can deploy a satellite. They can either spin it up and kick it out, or they can use the Canadian robot arm to lift it up out of the payload bay, hold it just above there, and then gently release it, and then the orbiter will back away, leaving it there in that orbit. The other thing they can do is the astronauts can put on their own personal spaceship, their own spacesuit, and you go outside and play. It's just so cool. I can't imagine. Just here's your faceplate right here. Below you, 200, 300 miles below you, going by at 5 miles per second is your home planet, and you're just floating above it. I can't imagine anything that would be cooler than being able to do that. Once we've done all that very cool stuff up in space, it's time to come home. Somewhere halfway around the world, sometimes over Australia, they'll turn the orbiter around backwards, fire those orbital maneuvering system engines again for the last time. At this point, the orbiter is really nothing more than a brick with wings. But because the astronauts are such good pilots and because they are trained so well, half a world away, finally back here at Kennedy Space Center, they bring it down to a perfect pinpoint landing almost every time. We hook up all of our safing equipment, make the vehicle safe for the astronauts to get out. They do that, and then we tow the orbiter back to the orbiter processing facility, and we start this whole process that I just described to you all over again. And that, my friends, is how we get shuttles ready to go fly here at Kennedy Space Center.